Hello everyone. Today I am going to solve one problem on driving point impedances, transfer impedances and voltage transfer ratio for a following network. Okay. So let us consider this network. So this is a given network, so which is in a time domain. So I am changing this into a frequency or S domain. So this network becomes V1 of S. R is simply R, and if we want to change it to time domain to frequency domain, replace the R with the R value only, C with the 1 by SC value, L with the S into L value. So here I am simply replacing the here 5 ohms resistor, 5 ohms resistor with the 5 ohms resistance value. Similarly here it is 2 Henrys inductance, so this 2 Henrys is nothing but simply 2 into S, nothing but 2S values. Similarly 2 ohms resistor with the 2 ohms resistance value. Here the capacitance value is 1 by 2. So we know that if we want to change it to S domain, so C is nothing but a 1 by S into C. So here it is 1 by, so C is equal to 1 by 2 now. So 1 by SC becomes 1 by S into C value is 1 by 2, means here we will get a 2 by S value. Substitute that 1 by 2 in time domain, in S domain it becomes 2 by S. So here we have to find out the driving point impedance. Driving point impedance is nothing but here input voltage by input current, V1 of S by I1 of S. So here by the application of KCL or KVL also will get, or we can take down the directly impedance value. So Z11 of S is equal to, so these 5 ohms impedance is in series with the 2S, so it is 5 ohms is in series with the 2S, but this 2S is in parallel with the this 2 ohms resistance or 2 ohms impedance values. So 2S is in parallel with the 2 ohms plus, but this 2 ohms is again series with the 2 by S value. So this is the total impedance of a given circuit. So it is 5 ohms impedance is in series with the 2 ohms impedance. This 2 ohms is in parallel with this 2 ohms. Again this 2 ohms is in series with the 2 by S. So upon solving this, we know that if any two impedances are connected in parallel, so its equivalent impedance value is nothing but R1 into R2 by R1 plus R2. Simply substitute that values here. So here 5 plus 2S is in parallel with the 2 plus 2 by S, so it becomes, take down the LCM here, so it is 2S plus 2 by 2. Now this combination is a parallel combination. 2S is in parallel with the 2S plus 2 by S value, so it is nothing but R1 into R2 by R1 plus R2. Simply substitute that values here. So here we will get a 5 plus of 2S into 2S plus by 2 by S by 2S plus 2S plus by 2 by S. Take down the LCM here and take down the LCM and cut down this denominator part as S. So here you will get a 5 plus of, it is 2S into 2S plus 2 now, so it is 4S square plus 4S by, take down this else as a LCM, so here you will get 2S square plus 2S plus 2 by S. So cut down this denominator term. So here we will get 5 plus of, here we have the 4 and 4, here denominator we have the 2, take down the 2 as a common term, here you will get 2S square plus 2S by S square plus S plus 1, cancel out these terms. So here we will get the total impedance is nothing but 5 plus 2S square plus 2S by S square plus S plus 1. Again take down the LCM here, so you will get 5 into S square plus 5 into S plus 1. So it is 5S square, 5S plus 5 plus these terms. So 2S square plus 2S by S square plus S plus 1. So upon solving this, here we will get a 5S square plus 2S square, means we will get a 7S square plus 5S. Here it is 2S term is there. So we will get 7 plus 7S plus 5 by S square plus 1. So that the total driving point impedance it is Z11 of S is equal to 7S square plus 7S plus 5 by S square plus S plus 1. Okay. So this is the way we have to find out the driving point impedance. Next we have to find out the transfer impedance value. So which is nothing but your V2 by I1. So next one is our transfer impedance value, which is V2 by I1. So which is nothing but a Z21 of S by Z21 of S. Here Z21 of S is nothing but V2 of S by I1. So here we have to find out the what is V2 of S, what is I1 of S. So here this V2 of S is nothing but. So from this given circuit we can say here we are making this port as open circuit, and so I2 0. But what is the voltage here? This voltage is nothing but the drop across these impedance value. So the drop across this impedance is nothing but, so let us assume this is I1 current, this is I2 current, we make it as a 0, and let us assume that this is an intermediate current as Ix. So the voltage drop across this component is V2 is equal to this Ix current into 2 by S value. So therefore this V2 of S is equal to that Ix current into 2 by S value. Here now we have to find out this intermediate current value. So to find out this intermediate current, here I am applying a current division rule to this one. So it is, so in this one here we have to find out the current. So it is, I am applying a current division rule. So up to here the current it is I1. Again it is divided into this 2 ohms impedance, this 2s impedance, and 2s impedance. So therefore the total current across these branch is equal to total current into, so that we know the formula, the current division rule formula, Ix of current branch is equal to up to the total current into opposite branch resistance by opposite branch resistance plus current branch resistance. So here the current branch resistance is nothing but here 2 by S na. So here this is your current branch resistor, then the opposite branch resistance it becomes here this 2S value. So up to here the total current is I1 na, therefore Ix value is nothing but your total current I1 into its opposite branch resistance here now, this is 2s, this is your current branch, this is your opposite branch resistance. So therefore here the total current is I1 into opposite branch resistance is 2s by opposite branch resistance 2s plus here this is opposite one, this is the current one, this Ix is in flows from this 2 ohms impedance and this 2 by S impedance. So it is 2s plus 2 by S value. So take down the LCM value here. So therefore I1 into 2s by 2s square plus 2s plus 2 by S. So take down this denominator term to numerator. So you will get Ix is equal to I1 into S square plus S plus 1. So this is your intermediate current. But here we have to find out the V2 of S is equal to this intermediate current into 2 by S. Simply substitute Ix here. So V2 of S is equal to, I am substituting Ix value here by into 2 by S. So here we will get V2 of S is equal to I1 into 2S by S square plus S1 S plus 1. So therefore from here we have to find out the transfer impedance now, which is Z21 of S is equal to V2 of S by I1 of S. Simply substitute V2 of S here. So it is I1 into 2S by S square plus S plus 1 by I1. I1 is nothing but I1 of S now. Simply cancel out this term. So here we will get a Z21 of S is equal to 2S by S square plus S plus 1. So this is your transfer impedance value. So in our question they asked one more term to find out the voltage transfer ratio, which is denoted by Z21 of S, which is equal to V21 of S by V1 of S. Already we know V2 of S is equal to I1 into 2S by S square plus S plus 1. Here now we have to find out this V1 of S value. So consider this network diagram again. So from here the V1 of S is equal to 5 into I1 current plus 2S into I1 current. So this is a mesh 1 loop now. So here it is I1 current, and in this one it is Ix current, which is exit current now. So it becomes V1 is equal to 5 into I1 plus 2 into I1 minus of Ix. So here see the equation now, 5I1 plus 2S into I1 minus of Ix. But we know Ix is nothing but I1 into S square by S square plus S plus 1. Simply substitute this value here. So he'll get 5i1 plus 2s into i1 minus 2s into ix. Now ix is nothing but simply i1 into s square by s square plus s plus 1. So here in this all terms I1 is common. I am taking the I1 term as common. So you will get 5 plus 2s minus 2s into s square term now. So you will get minus 2s cube by s square plus s plus 1. Take down the LCM. So you will get 5 plus 2s term into s square plus s plus 1 means we will get 5s square plus 5s plus 5 plus this 2s into this term means plus 2s cube plus 2s square plus 2s minus of 2s cube. So here from here we can cancel out directly 5s cube 2s cube minus 2s cube by s square plus s plus 1. Therefore the total voltage V1 is equal to I1 into upon adding these values here we will get 7s square plus 7s plus 5 by s square plus s plus 1. So this is your V1 value now. So V1 of s. So therefore Z2 of s is equal to Z21 of s is equal to therefore G21 of s is equal to V2 of s by V1 of s. So V2 of s is nothing but I1 into 2s by s square plus s plus 1. V1 of s is this is the value. Now here simply substitute these values. So denominator terms will get cancelled. Therefore G21 of s is equal to 2s by 7s square plus 7s plus 5. So by this way we have to solve this impedance values. Okay. Okay. Thank you.